Welcome to Advanced Data Analysis 1 with me, Erik Erhardt, Professor of Statistics at the University of New Mexico. In this video, I'll help get you started with Class 20 on hypothesis testing applied to your project. So we'll jump down to the timetable to week 20, where we are going to be doing this class. And there's no RMD file here, no R Markdown file, therefore the project or this assignment is in your project file. So we'll open up our studio. And open up our project file. That looks like the last one we worked on. And because it's a new, I'm working on this new, I'm just going to update the day to today's date. I'm going to set the working directory in the session, working directory to source file location, and in the markdown file, let's find this class number. So if I search with Control F for class 20, here we are for hypothesis testing. Great. Let's run everything down to, I'm not even sure I have a code chunk down here, but I want to run everything down to the beginning of the next code chunk. Looks like I probably can run all the code chunks because there's probably nothing after this point. So I'm going to go up to run and do all, run all. That's going to run it in the console. I will also knit the document to make sure that we're starting with a document that knits. So I have two environments happening at the same time here. I've got the console running stuff, and in my markdown environment, it's also running stuff. Okay. Let's see. Let's get started with reading the assignment. So I start off up here with the mechanics of the hypothesis test. We have seen this before, so I'm not going to cover it here, but in a previous assignment, I walked through those steps. I also have some comments here about what do we do about the word significance, and I recommend that you read this on your own. My main comment here is that the word statistical significance is often misunderstood outside of statistical circles, and even sometimes for people who work with statistics quite a lot. And I recommend giving a little more context whenever we say something is statistically significant. So I guess I'll just leave it at there. All right, let's open this in the browser. And if we jump down to class 20, it'll be easier to read it here. Should jump. Let's try that again. Class 20. All right, so there's the mechanics of the hypothesis test. We'll skip through that. What do we do about the word significance? It's worth reading this to understand how that word is used. And here is the assignment for today, just the 2-sample t-test. When I asked you to put together your rubric for your project, I asked to have a numeric variable and a categorical variable with 2 levels. Those are the 2 variables that you'll need for this assignment. So it reads, let me make this a little bigger if I can without it jumping around too much. Here we go. Using a numerical response variable and a 2-level categorical variable, or as you know, we can reduce almost any variable down to 2 levels. Specify a 2-level t-test associated with your research questions. So, you know, that sort of just means that it sort of relates to your data. All right, and these are the 6 steps. One of them is not really worth anything, but required to do everything else. So first, specify the hypothesis, the hypotheses, the null and the alternative hypotheses in words and notation. And this could be a one-sided test or it could be a two-sided test. It's up to you. If you feel like, you know, for example, if you're thinking about like people with depression and smoking or alcohol use, maybe you would make a prediction that people who are depressed either smoke or drink more than people who are not depressed, something like that. And so that would be, if you have a greater than or less than, that would be a one-sided test. If you just say people who are depressed will smoke or drink a different amount than people who are not depressed, that's a two-sided test. Next, use the t-test function to calculate the mean, test statistic, and the p-value. Then state the significance level. Right, that will typically be alpha equals 0.05. The test statistic, report that from the t-test, and report the p-value. From the p-value and the significance level, state the conclusion in the context of your problem. If the p-value is less than alpha, the significance level, if the p-value is less than alpha, then you reject the null in favor of the alternative and say that there's a difference. But if the p-value is large, then you'll say that we have insufficient evidence to say that there's a difference. Given your conclusion, could you have committed a type 1 or type 2 error? This is a question that we've repeatedly seen in the previous assignments. And finally, and perhaps this is often the thing that I do first, provide an appropriate plot of the data and the sample estimates. That means, right, so plotting the data might be having 2 histograms or 2 box and whiskers plots with points on top. The sample estimates will be, if you've got histograms, you can have some lines on there, or if you have got box and whisker plots, you could have a point for the means, and then label the axes in the title. And there's code for all of this stuff in previous assignments. So what I will do, I'm going to try to use code that we've seen already from previous assignments, but I'm going to go to my previous year's version of this to choose the questions to answer. That is the variables I'm using for this test. So I think we are down here. Okay. So I'm looking at total cigarettes smoked by depression. And let's just take a quick look at how modern this code looks. This looks pretty good. I think I can use this. Sorry, I jumped around for a moment. All right, so I'm going to go over to RStudio, go down below all these questions, make some space. I'm pressing and holding enter for a while, and put in a code chunk, Control-Alt-I, paste in this code. So I'm starting by starting with my data set, grouping by the depression variable. Depression is my binary categorical variable. And then I'm summarizing, that is, I'm calculating the mean of the total cigarettes smoked, and then ungrouping. And one thing I'm doing with this mean is if there's NAs, I'm removing them before we calculate the mean. If there was an NA in there and you tried to calculate a mean, any calculation with an NA results in an NA, and that's not a useful mean for us. Then I'm plotting the data. Depression is the X variable, Y is there. I think I don't want to do the box plot. Let me do the histogram. I like that much more in the previous assignment. All right, let me go back and grab a little bit more code. So that's sort of what it's going to look like. It's going to be a bit different because I have a different subset of data in my assignment. Oh, here's what I want. I've got a histogram. So I've shown examples of both of those. And I guess I'll just leave both of those in my example. We've got the code that does the t-test, which we'll talk about in a moment. And then we've got the 5 steps of the hypothesis test. And that should be everything. All right, so let me scroll up now to the hypothesis test mechanics. I'm going to copy this code because it gives me a good place to start for any hypothesis test that I'm going to perform. And I'm going to paste that underneath all of my results. Okay, so now I sort of have all the raw materials that I need. Let's go back to the rubric and go through in an ordered way each of the items. Okay, specify, and I might change the hypothesis from what I did previous year. All right, so first, specify the hypotheses in words and notations, either a 1- or 2-sided test. All right, so let's, I keep spelling things in the British English way. All right, so we'll set up the null and alternative hypotheses in words and notations. So I'm going to make a prediction, having seen the plots but not really digested them. As I discussed at the very beginning, maybe people who are depressed tend to smoke more. That's going to be my alternative hypothesis. So I'll say the population mean for the population mean total cigarettes smoked, and I'm just going to put in, this is unnecessary, but I'm going to put in the variable name in parentheses just as a way of being very specific that that is the variable that I'm testing. The population mean total cigarettes smoked is greater for people with depression than for those without depression. And that variable is around here somewhere. Here we go. Now I always copy and paste variable names. Even I know how to type the word depression with a capital D. It's just that I know that if I copy and paste it, it will not make an error. I will not make an error that way. All right. Okay, so the main thing is here, greater for people with depression. All right, I've stated it in terms of the alternative hypothesis. In notation, so I'm going to do the mean for people with depression is greater than people without depression. Maybe I'll just do n, underscore n. Versus, and then this is going to be, oh, that's the null, excuse me, this is the null hypothesis, so that one is equal. And let me copy this, and I'll put it over in the alternative. The alternative is that people with depression have a greater mean for the total number of cigarettes smoked. Cigarettes smoked. All right, choose a significance level, 0.05. Our test statistic we're going to see in a moment. Determine which tail. That will sort of be determined by the order of the two variables. So we'll come back to that in a second. And then state the conclusion. We need to see the results. Okay, so we're getting some of the, okay, so we finished 1 and 2. We're going to let alpha equal 0.05 be the significance level. Let's scroll back up to the rubric and see where we're at. Specify the hypotheses. Good. Use the t-test to calculate the mean, etc. All right, so let's run some of this code. Now, this is all the plotting code. We could, to make this a little more in the order of the rubric here at the top, I'm going to move some of this code around in particular, the t-test is what comes first. Let's see, what if we do one right here? Oh, it knew how to end and start a new one when I did Control-Alt-I. That's pretty smart. All right, so I'm going to do my t-test right there, and I'm going to move my plotting stuff down below. Okay, sorry, I hope you're following what I'm doing. I'm just sort of reorganizing. So I've got specify the hypotheses. So I've got my t-test stuff up here. You know what? Let's have that be the second step. Okay, set up the alternative, or set up the hypotheses. Then let's run this t-test. And let's walk through the code here for the t-test. Why did that indent so far? All right, so we have the y variable, that is the response variable, total number of cigarettes, that's the numeric variable on the left, tilde, and then depression is the categorical variable from the NESARC sub data set. And then you can say data equals, it doesn't really matter. All right, that's going into my T summary, and I've got here TCS, total cigarettes smoked, underscore depression. All right, let's run this and see what the result is. We'll check for errors. Okay, so it ran just fine. And we get, oh, but our code is not correct, right? And I'll show you why I know that, other than just remembering. The alternative hypothesis that we're testing is that the true difference in means is not equal to 0. And I actually want it to be greater than. That is, the depression group is greater than the no depression group. Now look here down at the bottom, sample estimates. The no depression group comes first, and then the yes depression group. So which order, either less than or greater than, if we're looking over here at this alternative code, which of these, less or greater than, do I need to specify? It needs to be in the order consistent with my hypothesis. So if I find the hypothesis up here, I've got my depression group in my alternative is greater than the no depression group. So this sign basically needs to be swapped around to be consistent with this. I've got no depression first, and then yes depression second. So that means that in my code, I need to put in the alternative is less, because the no depression group is going to be less than the yes depression group. That's my hypothesis. And based on the means that I'm seeing here, it looks like that's consistent with what the data say as well. All right, so now let's run this code. Now I've got the true difference in means is less than 0. Great, because the difference I'm taking is the no depression minus the yes depression. And since the yes depression has a minus sign, we're expecting a negative number, which is less than 0. All right, so we have a t-statistics of negative 17, which is massive. That's because we have a degrees of freedom that's 10,000, which is, we have a very, very, very big sample size. And a p-value that is smaller than 2.2 times 10 to the negative 16. So that's a 0 point with 15 zeros and then a 2, and it's even less than that. So it's effectively a p-value equal to 0, even though you can't have something equal to 0. Okay, so anyway, that is a very, very, very strong evidence that, in fact, there is a difference, and the difference goes in the direction that we were expecting, that the depression group smokes more than the no depression group. All right, so we can return. Let's see, do we want to print out some of the values directly? We can look at the names of that. And we've got our statistic, which is our t-statistic. That's the negative 17 right here. And we've got our p-value, which is actually times 10 to the negative 66. Okay, you know, that's 0. All right. Anyway, so we've got some of the things that we need there. So let's go back to the rubric, make sure what we're doing, that we're following everything. We've got specify the hypothesis, use the t-test, great. State the significance level, we did that, alpha is 0.05. Test statistic and the p-value. All right, perfect. So there's our significance level. Our test statistic equals, and I'm just going to sort of remove all that and say the t-statistic equals, it's this statistic down here. Okay, so I'm going to put 2 left ticks. Inside I'm going to put R space and paste in my statistic. And we only really need that to 3 decimal places. Let's see what this gives us. Oh, are you kidding me? I just want to press Control Enter. It's I'm going to copy and paste it. Yeah, I'm within dollar signs, so it's trying to interpret it as code. Okay, good. Negative 17.2, 3 significance digits. That's pretty good. I also need the p-value. Okay, determine the tails of the sampling distribution. We don't really need to specify this right now, but we correctly chose the tail before when we specified less. It was the left tail. So really all we need here is the p-value. Okay, so I'll just say the p-value is p equals, and we saw it down here, it was this t summary $ p dot value. So I'm going to put 2 left tick marks, R space, that, and 3 digits should be fine. Now I think that will give it to us in scientific notation. Yes, so 6.85 times 10 to the negative 66. All right, let's scroll up and see how we're doing for our rubric. Okay, state the significance level, test statistic, and p-value. That is done. State the conclusion in the context of the problem. So we'll scroll back down to state the conclusion. So we have a p-value that is very, very small. And we have a alpha level, significance level of 0.05. So because the p-value was less than alpha, we're going to reject H0 in favor of HA, concluding that people, and we can sort of go, one way to help yourself write this conclusion is you can go back to your original statement of the hypothesis and use the words you already wrote, because you wrote out the alternative hypothesis. So let me just copy all of this and we'll make some edits below. So I'm taking my alternative hypothesis, putting it down here for the conclusion, concluding that the population mean total cigarettes smoked is greater for people with depression than for those without depression. Period. Perfect. We rejected the null in favor of the alternative. Therefore, we can just state the alternative as long as we originally described it completely. We've got a great conclusion there. All right, I feel happy with that. Let's go back and look at the rubric. All right, given your conclusion, could you have committed a type 1 or a type 2 error? All right, so what did we decide? We decided to reject the null in favor of the alternative. Recall last time, type 1 and 2 error. There was a great Wikipedia page on that. Oh, the one right at the top. Okay, and this is what I showed you in the video, in one of the last videos. We have the true state of nature up here, whether the null hypothesis is actually true or false. This is the state of nature, but we don't know the state of nature. So we collected a sample, we performed our statistics, and we made a decision. And in our case, we decided to reject. So if we rejected the null, and the null happened to be true, that's this column, then we could have made a type 1 error. On the other hand, if the null hypothesis was false and we correctly rejected it, then we would have been correct. So because we rejected the null, we could have made a type 1 error. So I'm going to copy that text and I'm going to bring it back over here. We could, because we rejected the null hypothesis, we could have made a type 1 error. I'm going to just put a $sign there to make it sort of a list item. All right, scrolling up to our rubric. Given your conclusion, we could have made a type 1 error. Now in your case, it's if you had failed to reject the null, right? So your data were consistent with the null hypothesis. If you didn't reject, then if the state of nature was the null hypothesis was true, then you would have been correct. Otherwise, if you didn't reject, but the null was false, then you made a type 2 error. Okay, so that covers both scenarios. All right, finally, provide an appropriate plot of the data and sample estimates in a well-labeled plot. All right, so let's scroll down and finish that part, and then this assignment will be complete. So the first thing I did was create some summaries. In fact, it would be nice to print out that table after we made it. Okay, so I've got my depression categories and I've got the mean cigarettes smoked, 173 and 253. Now, we've seen this code before, so I'm not going to really go over it. Let's just run these plots. I'm going to highlight and press Control Enter. Aha! Some of my code, well, they continue to develop the tidyverse, and so I'm getting a warning here that in stat summary, the function.y is a deprecated argument, meaning that this used to be how it worked, but they've since changed it to just fun. So I'm going to change that as well and rerun that code. Okay. And my plotting window is a little too small. The other advantage to doing the histogram is that it's not trying to plot 10,000 points. It's just making, a dozen bars. So I resized it. It has to replot those 10,000 points. But we've got diamonds at the means. I didn't put any confidence intervals because in the rubric I didn't ask for them, but I could have put confidence intervals there as well. The stat summary computes the mean. Oh yeah, I think I'd do that differently. Well, anyway, this works just fine. Here in the histogram, I do it differently. With the vertical lines, the plot finally updated. This looks pretty good. Now we've got really right skewed data here. I wonder whether our model assumptions are met. We're going to be assessing model assumptions in a later assignment for our own project. So I'm not going to, well, should I worry about it? Maybe I'll modify the assignment before I have you guys get to it. It would be good to check the model assumptions here. Okay, anyway, because my data are really skewed. Okay, all I was saying is that for the vertical line, I'm using the data set that we created that has the summaries in it right here, and plotting those as x-intercepts. For vertical lines, I specified the total cigarettes smoked as the x-intercept. So let's take a quick look at this. bin width equals 40. You may have to modify the bin width to look good in your case. Wow, look at how right skewed that data is. It makes me wonder too whether, let me take a quick peek at who is in my sample, because if I'm using when cigarettes smoked equals 0 in there, look at, there's a bunch of zeros. I should probably restrict this to only people who are smokers. Let me go back and make a couple edits, because I think if we're going to look at depression and smoking, well, this is people, I'm looking at people with depression and asking who smokes more. In that case, it probably makes sense to include people with 0 smoking in there. I do get this big spike for people who are not smokers. Right? So this is a choice you could make in your own project. If you're interested in people who smoke and are depressed, well, or let's see. Yeah, if you're basically interested in smokers and asking about who's depressed versus who's not depressed, then it could make sense to restrict smoking to positive numbers. In this case, I've framed the question differently. I've phrased it, among people who are not depressed versus depressed, who smokes more? That probably should include people who are non-smokers as well. So I feel okay about this again, that we should keep the zeros in there. All right, I think I'm going to add the testing model assumptions. I think that is a good thing to do here. Let's open up a previous assignment where we tested the model assumptions from class 19. Now this is a 2-sample test. I'm going to jump down to the bottom. If I jump to the very bottom, I've got my code here for a 2-sample assessment of model assumptions. I'm just going to copy that over here after all my plots. You know what? Let's put this above these plots. Oh, it doesn't matter. We'll put it at the very end. All right. The data set that I'm looking at is NESARC sub, and I've got the people who are depression equals, and then that label. So let's look at depression, and we'll look at the labels. Oh, that doesn't work. Levels. All right, so we'll do no depression was the one that was coming up first, so we'll make that the first one in the plot. And then the value that we're pulling is the total cigarettes. Total cigarettes smoked. Okay, so I'm going to do the same code for the second part, but I'm going to say yes depression, and we'll run this code. This is taking a little length of time because it's resampling fairly large samples and it's doing it 10,000 times. Yeah, see how long that's taking? I think that's not just something weird because my fan is on. Oh, maybe it is. Okay, hold on a second. I'm going to press escape. Okay, it's not responding. So it was running. Let's look at this code on the website while that is running. And I'll show you where you can change how many runs. So we got bootstrap 2. Okay. So this function is a function. You put in 2 data sets and you specify the number of iterations. Right now this is 10 to the 4th power, so 10,000 times. So if we add an argument and reduce the number of resamples, that's fun. Yeah, I guess we'll terminate R. It should just kill the stuff down here. Up here, we should be able to save our work. Okay, so I want to specify, I'm going to maybe do, I'll start with 100. And then if that's going to go very, very fast. And we'll update it, we'll probably up it to 1,000. Okay, I'm trying to save my document. Well, we have done everything in the rubric except for checking model assumptions. I am going to, there we go. Okay. All right. Let's see, I think I can do, oh, it's going to do it for me. Okay, I'm going to save my file very quickly. Let's run all the code down to here. And then we will, oh, it didn't like that, didn't like that, didn't like that. I'm pressing escape down here. Because when R restarted, I need to set the working directory again to the source file location. Check out the environment, it's empty. All right, let's run everything from the top. Sorry, this is probably a little bit confusing. Because my R crashed, because I tried to stop a fairly computationally intensive operation, R wasn't responding because it was busy working, and it wasn't checking back to say, hey, are you trying to interrupt me or not? Eventually the operating system said, hey, it's not listening to you. So then R restarted, and when it did, I needed to reset the things that the console knew about, in particular the working directory, and that's it. All right, so looks like we should have a plot down here. Okay, that's where we left off. Let's run this now. Let's put this in here and say 100, just to get a quick look at need finite x limit values. Now this, I think, see error in plot window. So the plot window is this window over here. I think it's just that this is not large enough. If we make the plot window a bit larger and then go back down to find the code. Okay, here we are. Let's try running this again. Interesting. Okay, so this could also be that this window right now is white, and let's reset the plot window. It might just have some settings from a previous plot that was interfering with the current plot. So now let's run it, and it, oh, interesting. So maybe it still needs to be even bigger. I'm not sure. Let's see what else it could be. Xlim, Ylim needs finite X limit values. Well, this is disappointing to be trying to debug as part of a video. What else? Let's take a look at the data sets I'm putting in here. There's one. And, oh, do I have any NAs? I might have some NAs. How many of these? Some is NA. Okay, I'm doing some code real quick. Okay, I've got 270 NAs. I think that is the problem. Let's add a line here that, or add a and then. I think we can do NA omit. Let's see if that works. No, I'm getting some strange numbers there. I'm trying to think of a sort of a classy way to do this. Okay, I think we can do drop NA and do total sig smoked, and then pull the variable. So first drop the NAs and then pull it. So let's add that code here to the second row as well. And we'll try running it. Aha! So it was NAs. There's our plot. I should update my code to drop the NAs automatically. Alright, so let's take a look at the assessment here of the model assumptions. Sample 1 is right skewed, sample 2 is right skewed, but that doesn't mean that our sampling distribution is going to be right skewed. At the bottom, we've got our bootstrap sampling distribution of a difference in means, and the black curve is from our sampling distribution. And in fact, we only did 100 observations here. Let's do, or bootstrap repetitions, let's up that to at least 1,000. Sorry, whenever I resize these windows, it jumps around. All right, let's do 1,000. You won't have these problems because you're not recording a video. Let's try this. It's going to give us a better version of our bootstrap sampling distribution. Okay, recall that the red curve is normal distribution. Oh, look at that. So the variability there was just that we had a fairly small sample size. Let me just show you something. If we did 100 samples and did this several times, watch how the sampling distribution at the bottom, how much variability there's going to be. So here's one. That looks pretty good in terms of normal distribution. Let's run it again. And I recommend that you try this out on your own data too. This one looks not too bad. There's a bit of a gap here between the red and the black lines. Let's run it again. But that first one that we saw wasn't looking very good to me at all. This one looks maybe a little bit wonky there. The problem is that we just don't have enough resamples of our data. But if we up this to 10,000, oh, that one looks pretty good. If we update this to 1,000, it's going to look beautiful. So even though our data is really right skewed for both samples, the difference in means is basically normal. The sampling distribution of the difference in means is normal. So I feel really good about the model assumptions here. I'll conclude that the sampling distribution of the difference in means, in fact I'll say the bootstrap sampling distribution of the difference in means, that's the title of this plot down here, is I'll say close to normal. So the model assumptions are met and we can rely on the decision we made in the hypothesis test above. That's my conclusion. Pretty good. I will add to the rubric, and I guess I'll modify these points a little bit to add, you know what, I'm going to steal from the previous assignment the assessment of model assumptions. Okay, sorry, I didn't mean to show you all the behind the curtain stuff. Assess, check the assumptions of the test using the bootstrap, and interpret the bootstrap sampling distribution plot. Okay, there we go. All right, that is the assignment completed. Let's knit it, make sure that it looks good, but otherwise we're done. I hope that so my result was actually pretty interesting. Smokers, or rather, people who are depressed smoke more than people who are not depressed. It's quite likely that you'll have a hypothesis that where you fail to reject the null hypothesis. That is entirely appropriate. Additionally, if you conduct a test and then you find that when you check the model assumptions that the assumptions are not met, that is also okay. Right? So in the very bottom here where we assessed the model assumption, you would say the bootstrap sampling distribution of the difference in means is not normal. So the model assumptions are not met, and we cannot rely on the decision we made in the hypothesis test above. So that is how you would write that statement. We soon will look at non-parametric tests, which would be the alternative that you would use to a t-test for statistical inference or decision making in this case when the model assumptions aren't met. All right, so we'll take a quick look at what we've done. Class 20, there we are. Zoom in, now it's going to jump around. Oh, there we go. All right, this is a little too big. A little too big. Okay, class 20, I'm going to page down a little bit. Here's the rubric, the new rubric. Okay, we set up everything. These equations look good. I like that. Greater for people with depression than those without depression. I wonder why that's going out so wide. I see that there's an issue here with these tick marks. I think it's because of the way that I put quotes. I need to correct this. In words, I just put the standard double quote symbol. I think that was the problem there. All right, I've got my t-test and the results. Choose the significance level, 0.05. There's my t-test number. That looks good. Here's the p-value. This is so nice. I just have the code there for the number, and our markdown knows to set this in scientific notation. That's beautiful. Then we rejected the null. Okay, that's very good. And we could have made a type 1 error, and I prefer to put a hyphen in there for type -1 error. Then we've got our plot. I've got this the table of the means, and we make some plots. This is a little bit big, but I should probably improve the labeling. So I'm going to go back and do that outside the video, since you know how to do that already. And same thing here. I'm going to improve the labeling on these axes, but otherwise this looks good. The means are in the right place. And then I've got my plot for my bootstrap. This looks pretty good. Now when you knit this is going to be different. It may be different each time depending on whether we've set a random seed. But anyway, this looks pretty good for normal, and there's my conclusion. Very good. My apologies for the long video. I'll see you in the next one.